All right, so we are continuing on with compound interest. So we're going to use the same formula, just a little tweaks here and there. Because what we're going to do is look at something called other compounding periods. Now, in the last class there at 10 o'clock, what we looked at was the fact that interest was being added after every year, right? So your interest was making interest. Or if you're borrowing money, the interest you owe is causing you to owe more money. Now, what has happened because of computers over the years and the fact that the people who have all the money are the banks, they've learned to add interest more often. And so there's different compounding periods, it's called. And for instance, there's 5 of them we're going to look at. The first one is semi-annually. So semi means 2. So the interest is going to be added twice a year with semi-annually. And then it gets even worse if you're borrowing money. Where you have quarterly, where you divide a year into 4 parts, and so the interest is added every 3 months. Then it gets worse. Monthly, the interest is added every month, so 12 times a year. Weekly interest, so it's added 52 times a year. Really bad situation if you're borrowing. And then, of course, daily interest. So interest is added every single day. It just keeps getting worse and worse and worse. That's how a credit card works most often. All right, so we're going to look at how that affects how we use this formula, the compound interest formula. So I get to example number 1 here, where unfortunately this is a true story, my true story. A computer is bought with a Visa card for $2,200 at a rate of 23.5% compounded monthly. If the bill goes unpaid, how much would it be 2 years from now? All right, so some things are going to be the same as what we did at 10 o'clock. Some things are going to be different. Now, in this case, and again, this is a true story, I borrowed $2,200 to buy a computer, a desktop, a long time ago. All right, now, it goes unpaid, and so I want to know how much my bill accumulated to. All right, now, the interest rate that I paid was 23.5% because I was in university. The younger you are and when you don't have a job, your interest rate is higher. You get more of a tax for borrowing because you are considered a risk that not to pay it back because I never had a job before. And so that interest rate as a decimal, right, was 23% or 23.5%. So as a decimal, again, dividing by 100%, I got 0.235. Now, here's how things change. Because this is being compounded monthly, I have to divide that interest rate into 12 equal parts. So I get a monthly interest rate. So I take my 0.235 and I divide it by 12 months. And so I end up with 0.019. And so that is now a monthly interest rate because this is being compounded monthly. N is the number of times the interest is being added. Well, in this case, this is going on for 2 years. But because I'm compounding monthly, each year, the interest is being added 12 times, once a month. And so for 2 years, I multiply it by 12 because there is, again, 12 months in a year. And so, in fact, the interest is going to be added 24 times, unfortunately. All right, so that's what changes here. The R and the N change. The A and the P stay the same. All right, so now I'm going to substitute those values in. And so my principal is I borrowed $2,200 to buy a Dell computer. In the brackets here, I have 1 plus my rate. All right, so I have 1, and then my rate, which is my monthly interest rate of 0.019. All right, and again, N is the amount of times my interest got added on to this bill I had. So interest was added 24 times, once every month for 2 years. All right, now just like we did before, everything is the same this way. It's just setting up my variables. Again, I'm going to do my exponent first. And so I get 1.019 to the power of 24. I get 1.57. And then, of course, I multiply it by my principal, $2,200, And I end up getting $3,454 is what I ended up paying for that computer after it was all said and done, because I had to borrow the money for the computer. And that was just a desktop 20 years ago. So again, I'm glad it lasted a while. All right, so my bill ended up being $3,454. And I was tricked into doing that in a way because, well, I was desperate. I didn't have any money, so I had to borrow the money. But I didn't realize what it was costing because they broke it down into monthly payments. That's how they tricked me. All right, they just told me how much I could pay per month. Made it seem a lot smaller. But a lot of monthly payments add up to a lot of money. In fact, $3,454. All right, so let's try another one of those, little compound interest. Example 2. All right, so once again, we're dealing with compound interest. So I go A equals P times 1 plus R to the power of N. All right, we have A, P, R, and N. I always like to sort out my givens, especially with this stuff, because they're a little more complex. All right, so we have a situation. A company borrows $10 million from the government at a rate of 8% compounded quarterly. So quarters. Interest is going to be added 4 times a year, every 3 months. If the money is paid back in 5 years, how much will it cost to pay the debt? All right. So again, we want to know what the debt is going to accumulate to, my amount at the end that this company is going to owe. But they did borrow $10 million. All right. Now, the rate we're looking at, well, we're going to start with N. Now, this is in quarters over 5 years. So 5 years, but because this is compounded quarterly, the interest is added 4 times for each one of those years. And so the net amount of times the interest is going to be added is 20 times. 20 times a year, or 20 times over 5 years. Now the rate, again, that's where it gets a little different. The interest rate here says it is 8%. Again, converting that to a decimal, I have 0.08. Now, that's the annual interest rate, where you have to convert it. Because we're compounding quarterly, we have to cut that interest rate into 4 parts. And so I take my 0.08 and I divide it by 4, and I end up with 0.02. All right. So again, that's the difference between the compound interest we did in the last class and what we're doing now. And so substituting in, everything's the same. We have $10 million was borrowed. All right, in the brackets, I have 1 plus my interest rate. So I have 1.02 in the brackets. And my N value, my exponent here is 20. All right, and then again, just solving using Bedmas. All right, so I take 1.02 to the power of 20, and I get 1.49. And of course, then I multiply it, 10 million by the 1.49, and I get $14,900,000 that would cost. So if somebody wants to borrow $10 million, compounded quarterly is not something regular people see. It's more of a business and government type of interest rate. You would end up having to pay back $14,900,000 after 5 years, just because you borrowed $10 million. Doesn't seem like it's worth it. All right, so there's example 2. Any questions so far? Let's see here. We got last one, number 3. All right, so example, well, we're sticking with compound interest here, so I'm going to write down my formula once again. All right, and again, we have our 4 variables. All right. So this time up, we're going with a student again who wants 18 grand for that first year of post-secondary school. So if, I'm going with a car, buy a car. So if a student wants to buy, and whoa, a little bit of, I missed some words here. If a student wants to buy a car, is what it should say, worth $18,000 2 years from now when they get their license, how much would they have to invest now at a rate of 9% compounded weekly? All right, so we're investing again, but we want to buy, this is terrible English on here, $18,000 car is what the question should be saying. I'll have to fix that. All right, so I want an $18,000 car. How much do I have to invest now to make that happen? All right, because a lot of you now get your license at 18, or your full G, I guess I should say. All right, now, this is 2 years from now. 2 years from now, all right? So there's our end. But this is being compounded weekly. So after every week, the interest is adding up, which is a good thing because we're investing here. But that is 52 times a year. And so the interest on this investment is going to be added 104 times. 52 times in year one and 52 times in year two. Now my interest rate is 9%. So again, convert that to a decimal, divide by 100%, and I get 0.09. But again, that's my annual interest rate. I need to convert it into a weekly interest rate because, of course, this is being compounded weekly. And so I'm going to divide my interest rate, my annual interest rate, by 52 to get my annual interest rate, which is then, to the first two non-zero numbers, 0.0017. So again, this is the tough part, the extra or the twist for this lesson. Everything else is the same. All right, so I'm going to substitute in $18,000 is equal to, I don't know my principal. And then again, in the bracket is 1 plus my interest rate. So I'm going to have 1.0017 to the power of n, which is the number of times the interest is going to be added. So 104 times. Okay, so again, Bedmus, I'm going to do my exponent over there first. All right, so I take my 1.0017 and take it to the power of 104. Definitely calculator work there. And I'm getting 1.197. All right, and of course, the last thing is to divide to get P by itself. So I'm going to divide by 1.197 on both sides. And so because this is compounded weekly, it's going to help me out a little bit, grow my investment. But to this day, I would need today to be able to buy an $18,000 car. I would still need $15,037.59. There we go. So again, that is compound interest with other compounding periods. All right, so that's, again, where you can add semi-annually, twice a year, which doesn't have very much. Quarterly, more of a big business, government kind of thing. Then there's regular people stuff where monthly, weekly, daily, where the interest is added. But again, the only difference between compound interest annually and other compounding periods is figuring out your rate, where whatever you're dealing with, whether it be monthly, weekly, or daily, and the amount of times that your interest is added changes. Because before it was just annually, so whatever years it was, that's what your end value was, because it was only added at the end of every year. But now, of course, interest is being added much, much more frequently. All right, so that's compound interest. This is the day before Christmas there, or day before Christmas holidays on Friday. We will be doing, again, compound interest, but we're going to look at finding the interest rate and finding the number of times the interest is added using our formulas. And again, some of the information or skills that we learned back last unit with exponential equations. Because again, if we're solving for n, we're going to have to take the log of both sides. All right.